Last year, we published a report on urban affairs. Currently, we are working on another report on infrastructure, transport infrastructure. We also work with land resources, water resources. During 2022 to 2024, this is our governing council, which consists of stalwarts in the geospatial industry. For these 2 years, these are our office bearers. And we are currently focusing on 4 verticals: infrastructure, urban development, water, and agriculture. So this is our strategic plan. We interact with the geospatial market. We do market analysis, gap analysis for geospatial technology. We also generate knowledge in terms of blogs, reports, white papers, and so on. We also work on policy advocacy, and we also do technical partnerships with various organizations like IITs and so on. We have sectoral committees for the 4 verticals I discussed. We have dedicated committees for all these verticals. We do partnerships and collaborations with key stakeholders from academia, research, and so on. We also work on skill development, capacity development, seminars, outreach and communications events, stakeholder engagement, and so on. So this was my presentation. Now I request our first speaker, Mr. VSS Kiran from Google Analytics, to start his presentation.
Thank you, Satej.
Thank you, sir.
So let me share my screen and confirm me once the screen is. I think you have to stop your sharing your screen so that I can share my screen.
Yes. Just a second. Just a second, sir. Yes, now you can share.
Fine, thank you.
Hello.
Yeah. So confirm me once you can see my screen. Is it visible? Hello.
Yes, it is.
Yes, it's visible to me.
Yes, we can see your screen.
Okay. Thank you so much. So good morning, students and faculty members and everyone joining for this webinar. So just imagine a city where the cutting edge technology seamless integrate to create a smarter, more efficient and sustainable urban landscape. Today, I am excited to discuss with the applications of drone and UAV in the context of smart cities and how they are revolutionizing the geospatial technology. Myself, VSS Kiran, founder and CEO of God Analytics and startup member of AGI. So before we deep dive into the technology, just to see the target, the vision of building cities for tomorrow. So let's take a moment to appreciate the significance of smart cities, the 100 cities as per the Indian government made, and the role of technologies plays in the development. Rapid urbanization, or you can talk about the couple with the need for sustainable and livable environments, demand innovations, or you can talk about the better solutions. Let's talk about the smart lights, smart traffic, smart parking, smart lighting. Everywhere, building cities for tomorrow is play as a vision to make the cities much smarter and the citizens to be smarter. The smart cities leverage technology to optimize resource and enhance quality of life to tackle complex and urban challenges. So how we can take? What is the key agenda? What is the learning outcome for the today? Let's think about the learning outcomes for the today's learning outcome. Why drones and UAVs in smart cities? Understand the applications of drones and UAVs in smart cities. Within that, we could discuss benefits of drone, types of UAVs and camera sensors, drone and UAV integrations, discuss one use case in infrastructure planning and monitoring in smart cities. Because there's a lot of use cases, we are not able to cover all applications, all different use cases in 30 minutes. I just give you the one single use case, very deep dive, so that you can understand how drone technology play very vital role in a smart cities. Then the complete process as a student, if you want, like after completion, you want to like plan your career in the drone, or you want to adopt this technology, or if like you're thinking about to start something or what. So what is the complete process? You have to understand the available software, or you can understand the complete process. What is the outputs to be generated, right? And generated outputs, how we can utilize. Then understanding the complete drone data processing workflow. Then automatic feature extraction from drone and UAV. Then Geo AI analytics on drone data. People are talking about the today's, like you can talk about ChatGPT, you can talk about the Google Bard or anything. DID, lot many AIs, but how geospatial AI and drone the merge together and create the different insights, so that the management or anyone can take the immediate decisions. Then finally the Q&A. So let's start and understand the why drone and UAV in smart cities. Let's see that why this my top screen share. My screen is visible?
Yes, it is.
Fine. Okay.
Yes, sir, yes.
So why drones and UAVs in smart cities? So understand the improved urban planning and infrastructure development is one of the major things. You can see the way the infrastructure is developing the day by day, or you can talk about the urban planning, master plans. Understand the how the reality in the ground, how the city is expansion. So the drone is always providing very high resolution images. So the improved urban planning and infrastructure development is one of the very important where the drones is required. Second, enhanced public safety and emergency response is another important thing. So when you talk about the public safety or emergency response, we can see that there is two type of the things. One, the drone which directly the survey and mapping. Another side where the delivery, where the emergency response, where the safety, multiple things are coming, where we can monitor continuously using the different sensors and cameras. So smart cities is not only the doing the data, but it's also doing the continuous monitoring or getting the alerts, or in terms of the emergency response, drones are playing very important. Then third is the efficient traffic management and transportation. So when you manage the traffic management, we know the CCTV camera feeds are there, normal traffic signals are there, but how best or efficient we can manage the traffic. So to understand that also, we can directly know that how we can manage very effectively. Then third, environment monitoring and sustainable solution for the rapid delivery and the logistic purpose. Then third is the cost saving and economic growth purpose. So this is also one of the very important. So to aspect these all, the drones are playing very important. But drones are not limited only the urban. It has also working this utilities. It also requires the agriculture. It also requires the forestry. Each and every sector. So infrastructure, you need to talk about the new constructions are happening when you want to monitor the construction sites. There's a new city like development plan, or you can talk about like the better manage the city. Okay, understand the city surveillance. So each aspect, this is very important. So what are the applications when you talk about the smart cities? These are 5 key applications I'm just going to tell about. These 5 are urban planning and public safety and emergency response. Then we have a traffic management, transportation, environmental monitoring and sustainable solution, right? Then we have a rapid delivery and logistic purpose. So all the aspects we need, like the drones and when you talk about the UAVs in smart cities. Just take the example of the first one, which I'm talking about, the urban planning and infrastructure scenario, or you can take. So when you talk about the urban planning infrastructure, the aerial survey and mapping of the urban planning is very important. Aerial survey is like when you talk about the UAVs unmanned aerial survey. So high resolution drone data playing very important role, one. And second thing, the video feeds which we require. So construction, site monitoring and inspection. Then the infrastructure, when you consider, so infrastructure maintenance and asset management also is one of the important. Now, the another one of the important I can talk about, the urban design and architect visualization. Okay, so the another thing we get to talk about, public safety and emergency response. So search and rescue operation is one of the important. Then fire, when you talk about when the fire incidents happening, like firefighting, disaster management, or you can talk about the traffic accidents investigation purpose. In the smart cities, we know that while a lot of infrastructure, people are like driving very rash, so a lot of traffic accidents are happening with the multi aspects. We don't know what are the aspects, but every day is a huge accidents are happening. So these all things, when you talk about this accident investigation, or you can talk about the control of the fire with the now that like drone sprays are available. So then another urban design, okay, when you talk about the architecture segment, so search and rescue where we have to play, right? So large designs architecture happening, 30 floors, 40 floors, and we talk about the Mumbai, 300 feet height buildings are there, 40 floors, 50 floors. So search and rescue operations can easy to do that under this public safety and emergency response application. Then talk about the traffic monitoring and congestion management. So just to talk about simple things like autonomous things, like when you talk about autonomous delivery, or you can talk about the transportation optimization or transportation system, intelligence transport system, I can say. So we can plan it accordingly. There the now smart cities, like I can take Hyderabad recently, the last year, the medicine delivery, food delivery, everything happened. So there is one thing. Then last mile delivery and transportation optimization is one of the very important aspect when you talk about the drones. Now the next factor I'm taking, the environmental monitoring and sustainability. So when you talk about the environmental monitoring and sustainability, under the smart city, we can see that a lot of sensors are installed in the different places in the smart cities, right? So when it's installed the different sensors, what is the reason behind this? Have you ever think that what is the main reason why these sensors are installed? How this can be work? So these sensors are sending the IoTs, right? So, but these sensors, when installed, is it enough? Some places they have not installed the sensors, or there's installed sensors a certain visibility range. So using drone, you can do the air quality monitoring. You can use water and waste management. Understand that where the water is stuck during the urban floods. Or you can talk about the green spaces and biodiversity monitoring, whether sufficient green space is there or not. When you try and do the regular survey, we can understand that how the entire city is managed very efficiently. Right? Then the renewable energy and infrastructure inspection is one of the important things, right? Under the environmental part. Then last is the rapid delivery and logistic, where the package and parcel delivery, which I given the example, medicine and foods. Then medical supply, transportation, and remote and rural areas, when from the cities to we have to disperse certain things, just to outside of the cities. So we require the drones facility, one of them. So as per these all things, what is the key benefits of the drones and UAVs in geospatial technology? Because we have the geospatial. Drones is one where the delivery, but we focus the how the drones in geospatial technology, this cutting edge technology help into the smart cities. There's a 4 key aspects I can say. What is the benefit? One is high resolution images we are getting. Second, we are doing the 3D modeling visualization. Third, we are doing the spatial data collection, analysis. Fourth, infrastructure monitoring and asset management, very key aspects. So, under the high resolution aerial imagery mapping, what you could able to do? You can generate the orthophoto with accurate mass, like 2 centimeter, 3 centimeter high resolution images. On top of that, you can do the land use land cover mapping, right? Then we do the urban heat island analysis, then disaster risk assessment. Then parallelly, the spatial data collection analysis you can do when this data has collected. Remote sensing data which acquired. The data can be processed for the LiDAR scan and point cloud data process, crowdsourced data collection, spatial analytics of the urban insights. So the 3D modeling and visualization, what we have to do, usually we do the building and infrastructure modeling. Today, people are talking about the BIM and GIS integration. So when you talk about the BIM is the complete CAD Revit file. Another side, we have the mesh data, which is generated by the drone. We can create the real view as it is how the building looks like in the ground, same to same, we get it, right? Then urban design and architecture visualization, right? Then virtual reality. Today, people are talking about the AR, VR, virtual reality of urban plan. So before we build something new, you can create using this drone technology, if you data, and create the AR, VR. So you get the real view of the city, how after building, how it looks like. Then infrastructure monitoring and asset management, right? So the structural inspection, utility inspection, utility again, the telecom, water, electric, transformer, everything. Then transport network monitoring. Then we have the compliances, right? So many things which we have to do it is required, right? So now then talk about the types of UAV and camera sensor. We know we see in the benefits, we see the application, we see the advantages. So how we have to, what are the sensors, what are the cameras are available? When you talk about the drone, to understand there's a different types of drones are available. Depend on the terrain condition, depend on the environment, depend on the wind factors, or depend on the the area which you want to coverage in a single day or multiple days. The type of the flyings. So the cameras and drones are available. There's a quadcopters, there's a fixed wings, okay? The fixed wing for 3 hours endurance, fixed wing for 1 hour endurance, the quadcopters, okay? Multi-rotors, okay? M210, that multi-rotor, Phantom is quadcopter. So multiple different type of drones are available now. These drones can be utilized further, right? For the drone survey, mapping, data collection, or videography, okay? Multiple. And there's a different type of the sensors available. Normally, we use the RGB, but apart from the RGB, when you do the inspection and all, we do the thermal sensor. And when you do the false color composition or understand the greenery of the area, we require the multispectral sensors. So whatever the sensors available in the satellite scenario, same the different sensors are available here. So what exactly, then we have these set of the drones. The next step comes to the integration of these drones into your regular workflow, where you have to integrate. You can take any of the below mentioned the particular domains, like agriculture, you want to integrate, you can integrate. Delivery segment, you can integrate. Utilities, as I mentioned, energy and power, right? Environmental monitoring, geographic survey, government, under, now I can say Swamitva project, NHA project. So all these, where the geospatial and the drone surveys happen. Then humanitarian, mainly for the health aspects, medical delivery, medicine delivery. Then industry operations, large industry operations within the industry itself. Now they have reduced the team members when you have to deliver the small kits and all. So they are using the drones. Talk about the any big industries like take the whether it's a iron or steel plant or I can say oil and gas. People are using drone to either in terms of the monitoring or in terms of the sharing the or sending the certain material to one place to another. Then infrastructure development, when you talk about the infrastructure, continuously monitoring, progress monitoring, understand the what is the progress. Then logistic in terms of the delivery, mining, how much mine happens, so understand the mine volume, create the different terrains, 3D aspect, 2D aspect, oil and gas, right? Then real estate purpose, real estate is again one of the important aspect where the people has continuously require. So suppose once the drone survey happen, I have the 2D photos, I have the 3D. Okay. So if this data can share with anyone. So as a client, as a customer, I don't need to visit to the ground to purchase any property. I get the complete view just to see the drone data. Then sports and racing, when the sports are happening, racing happens, that is also side the people are continuously capturing the data as a video. And later that is integrated with the full motion video, integrated with the GIS, where we are getting the track. So data collection process is one of the important thing, but this collection process is always depend on your domain or industry or the application which you are selecting. Just to give the example, when you want to create only high resolution maps, there is a edge direction we have to fly. But when the inspection of the any utility pole, we have to go to the circular survey from the bottom to top. So we require the 360 degrees. So same we want to construct the one building, the same to same real view. We require again the three. We have to do the either round or else we have to go the horizontal, vertical, both in the rectangle. So the type of the survey, okay.
Hello, sir. Hello, Kiran, sir. We lost you.
Yes, Kiran, sir.
Hello. I think we lost him. Kiran,
No.
we'll.
Yes, sir. Mic is mute.
Hello.
Yes, sir. Yes.
Yeah, yes, clear, right? So
Yeah.
please let me know that how long you lost the network so that I can talk about that. So the next is that let's talk about the construction monitoring part. When you talk about this construction monitoring, basically the drone is playing an important role one. So I'm just taking the example for the infrastructure monitoring today in the smart cities. So what are the places and how we can take? So drones in the mainly the construction industry is aspects of the 4 factors. One, we have to save money, right? Another thing, we have to save time, right? Third, we have to get the reduce the risk. Fourth, we get the provide utility factor, right? So this is the 4 factors: save money, save time, reduce risk, and provide utility. So drones is very important when you talk about to comparative with any other technologies, not only in terms of the real-time capture or when you have planned that time, but it also affect like in terms of the save money, time, right, and reduce risk. So how the main thing one, it's a smaller area. Like when we do the small construction industry, hardly is less than, I think, say it's around 6 lakh SFT or 500,000 SFT, right? So smaller area. So one drone can fly with a smaller area. It hardly take the 15 minutes or 20 minutes task to fly. Second, to process this image, which save the times. Third is the reduce risk. So if we go to send someone to the construction industry to monitor and do it, okay, there may be the risk factor. But to flying the drone on both the construction industry and to just capture, so risk we have to reduce completely. Third is the provide utility. drone provide complete utility benefit in terms of the stacking opportunities. So this, when you talk about the save money, when you compare with the satellite and other data sets, the cost is very high. If you go for the manually also, its cost is very high, where the drones can is optimize the complete cost. Okay. And it almost is, I can say, cost effective solution in all the aspects. If in the longer run, I can say 5 kilometer or 10 kilometer also, if you go and to want to monitor, it always beneficial when you talk about the drone. Second, the save time. How we save the time? Like if there is a place where we want to go, so we have to like rush into the traffic, the inspections. If I want to perform the particular area, with the new constructions happen within the smart cities. So we know that there's a traffic congestions. Then we have to travel to one place to another place. Then after visiting that, we have to like spend certain time. Then also we have to monitor each and every aspect. If its area is more than, I can say, like 10,000 or 1 million SFT and larger area, I can say. So to visit entire place, it always take time, and also I'm not able to maybe view the complete thing if it's a multi-floor buildings and infrastructure. So if the drone, I can fly the different angles and I can capture the overlap photographs, okay, and I can immediate process, and hardly entire thing can done within 1 hour or 2 hours. So I always save the time. If I go there and visit complete, it will take 7-8 hours. But here, I can send my drone at the job site and I can continuously flying the drone, capture the photograph, or I can directly view the real time in my screen. So my inspection is done, my monitoring is done, so I can save the time. Third is the reduce risk, because a lot of actions happening in the drone. Suppose only if someone has went for the inspection and there is nothing is happened, very risk is happened. So we have to lose the life. So to save the lives also, drone play important, where one of the important drones can reduce the risk. Then third is provide the utility. Better track and manage constructions. We require the regular monitoring, okay, with 2D and 3D aspects. And also to plan the proper utility, that how much utilities is required. So that aspect also is one of the important way we get the drones helpful. So drones applications are always cost-effective solutions. Why? Why this is only the cost-effective solution? Why not others like satellite imaging? If it's larger area, that's always better. We can go for the satellite. Smaller area. Sorry, any questions? Hello? Okay, fine. So using GIS drone mapping, increase frequency of the data collection first. Then weekly, bi-weekly, monthly visits. So suppose I want to go for the every regular visits. Regularly have to fly the survey, do the mapping. So I can go for the weekly, bi-weekly. High resolution orthomojects we are getting. 360 photographs. High reference points. Easily shaded and downloadable. So all the aspects is a cost-effective solution. So apart from that, there is important aspect when we talk about the drone in smart city. If you plan or design something, so if you are planning a new building within the area, cities itself, like city center, you want to plan to demolish the small area and plan for the large building, whether you can understand the proper direction, proper planning, what is the surroundings such cover. So you need the complete 3D view of the your surrounding places as well. So accelerate the construction project planning is also one of the important things which can be done using the drone. Then continue progress monitoring. So how the project, week wise, day wise, okay, every hour, how the progress is there, that can also be monitored using the drone technologies. Then the another important thing which I can say, the project management. So transformation construction project management using drone data. So you can process the drone, you can plan, get the video feeds, get the images, so you can manage your project properly. You can manage operational scheduling conflicts. So the same time you can do the multiple tasks, like I have to perform the inspection of the 6 buildings of the same construction sites. So what I have to do, I can send the 6 drones on the different aspects, collect the data, and same time I can visualize on the dashboard. So better project management. So what the advantages complete when you talk about this construction site and all, or new infrastructure within the smart cities. The picture which show you like how the data has captured. So one is the having bi-weekly or monthly snapshots we have to collect. Then second is the progress report we are getting for the asset management. And also we get the 1 to 3 minute video, right? Which with the simple 5 moving shots and digital delivery. The data can be delivered using WebGIS. We can see that also. So the mapping when we talk about, understand the one aspect, there are two types. One is the horizontal, another is the vertical mapping.
Excuse me, sir.
So month-wise, you can progress how the city is developed, what is the changes are happening on the cities. Then the smart cities, you can see that if any building you can move, you can continue progressively, you can monitor, you can create the 3D mesh and you can monitor that. Okay.
Excuse me, sir.
As accurate on the ground.
Hello, sir. 5 minutes are remaining.
Yeah. Then there is a couple of example application you can see, the visual inspection, progress photos, right? So one of the important then drone survey and mapping. You can plan and you can do with a much faster topographic survey. You can do that. Ground control accuracy, we can do that. So high definition maps, 3D models, and terrain models are the very 3 important factors which you can get it, right? So complete process is a 5-step process. Collecting this, first we do the survey, then process, then we analytics and land parcels and CAD drawings. So today, the drone data processing is much simplified. Simple upload imagery, perform adjustment and create products. So there is no manual. Today, AI is enabled much sophisticated, cloud computing is such a way. So it's very easy. Just to give you the example, if you workspace driven approach, if you want, you can use ArcGIS Pro. It's one of the software which again you can use Pix4D, AGSort, multiple things with the workspace driven. Why I have taken the Pro? Because not only the processing, after processing, you do the analytics also. So same, the workflow driven approach, you can talk about the drone analytics. So you can see that this is the one simple data sharing access visualization, data processing. If you scan this QR code, you get this application in your mobile right now. And you can visualize this data, what you can see on my screen. Okay. Then automatic upload, once you data browse and upload, and you go for the cup of tea or coffee, or come after 1 hour, your entire image process is ready and ready to use for the further products, right? So outputs, basically, we get the orthomosaics, 3D models, exports of the multiple file formats, elevation models, okay, and ground control point, reports. So many things we get the output. And the methodology, I can say, one is the required drone, second is the sensors, proper sensors required. Third is the softwares, which I highlighted the previous slide. Softwares required, the map output, and the final analysis part. So this is the once the data is ready, you can use AI to automatically extract the features, right? So here I can play you one small video, 1 minute, so that you can understand how it's work. Complete voice driven. Load drone image. You can see the just enabled disable. Extract building footprints. System is extract with the voice command. Okay, on drone image. Now select the plot. So with the go to 121 building number, you can directly hit the building number 121. You can also see the different information which is directly integrated with your MIS data. Go to 316 plot. So likewise, today the technology and this cutting edge technology changed the world, and the smart cities we can use much in multiple aspects. So this is one small example, the feature extraction, process the drone data, visualize the drone data on top of Google Analytics smart mapping platform, and extract analytics. So generate accurate digital model of your sites on a smart city and apply the computer analysis and automatically provide the business insights. With that, I'm just concluding this session. And I'm happy to answer if you have any questions, or else you can directly drop a mail to us. Okay, mail to AGI, mail to Godalities to get more understanding about the anything if you want to know. With that, thank you so much.
Thank you so much, Mr. Kiran. And in interest of time, we will take all the question answers towards the end of this session. I would like to request our next speaker, that is, just a second, that's Roma Chakrabarti from ISRI India, who would be talking about geointelligence for smart cities. Roma, I welcome you on this webinar.
Thank you very much.
Yeah, Roma, just check if you can share your screen.
Yeah, I'm checking. It is visible?
Yes, it is. Yeah. Can you just make it on
Yeah,
screen?
I'm doing.
Okay, over to you, Roma. Thank you.
A very good morning to everybody, all the students, the staff members, and all the rest of the speakers. So one thing I would like to apologize today, my throat condition is not very good. So if there is any disturbance, kindly excuse me for that. But I will try to be short, specific, and uninterruptive, so that my cough don't interrupt your views. Okay, so it is about geointelligence for smart cities. So dear friends, what I always believe and what I always tell, cities are living entities. Why? Cities are complex, it is ever growing. The main role of city administration is to deliver citizen services among all these growing complexities of the city. And smart cities always mean efficiency in delivering the services. And for that, we need the real-time data. So the crux of the smart city aspect is that it need to have an operational efficiency. And operational efficiency comes when we have data, and data through IoT and real-time things can come up in a continuous, in an unbiased, and in a speed mode. And now, what is smart means? It means improving operational efficiencies of a particular city. Now, why GIS is so pervasive to the smart cities? Let me remove this. Okay. So location data is critical for managing the delivery services. The cities gain efficiency when they improve data collection, data sharing, analyzing location-based data, and integration with other services. And in smart city, what are the deliverables? So it streamlines the workflows and business processes. Why? As I have told you, it is to improve the operational efficiency of city. And operational efficiency can increase when they are in the data is embedded in the workflows. So whenever the camera data is coming, whenever the sensor data is coming, whenever the SCADA data is coming. So we need to embed them in a business processes to take improved decision support system. And it improved the and this GIS also improve in the data collection process of the cities. Why? Because it can integrate spatial as well as non-spatial data, some discrete source, some unstructured data. So it can incorporate everything and imbibe a decision support system. GIS helps in analyzing the data quickly to change the pace of operation by government institutions. It provides you dashboards, the operational dashboards, whereby you can see the changes, you can analyze those changes, and you can create the decision. And it can help in analytics of improving decision making and provides meaningful information products to the public. Why now GIS is foundation for any of this ICCC concept? So ICCC is integrated command and control room. So what we have done to improve the efficiency of the cities, we have created integrated command and control rooms. Now the objectives of, what was the objectives of the control room was to see, okay, we have put up the cameras in the cities to look into where what type of problems are happening. Then we have put up the environmental sensors in the cities to get the environmental data. We have put up the sensors over the street lights to gather which lights are performing, which are not. There are different type of VMS systems which are for improving the information supply to the city in real time. There are Wi-Fi areas in the city. So all these are components of smart city. Now, all these components need to be in one platform for a decision making. Otherwise, you cannot take a decision. Like, suppose there is an incident of fire in the city. So you need to have all the assets which are there. First, the location where the incident has happened. So you need a very robust grievance management system that, okay, people have put up that there is a fire incident in the city. Then you have where are the nearest fire station. So you look into the nearest fire station, and when the fire vehicle is moving, you have to see that this is the shortest path. This is the most uninterrupted path. And then when it reaches to the place, the evacuation starts, and that time you need to see what is surrounding of that building where it has caught fire. So, and then evacuation of people and blocking the traffic so that there is no traffic interruption in the city. Now, all this, when you want to combine together, you need a GIS platform, because all these are discrete systems which are working, and their working can be uninterrupted only if they are on GIS. So what we say is GIS provides the foundation to ICCs. It maps the unstructured data. Unstructured data means which are coming from social media, which are coming from Access file, etc. Then there are tabular data of different type. There are LiDAR data, point data. Kiran has already covered about the most of the things for drones, etc. So terrain, imagery, voxels, vector, 3D, CAD BIM data. So that is also important component. Then there are real-time data from IoT sensors, multi-dimensional data from different places, from satellite images and all this over a same geospatial infrastructure for decision support system. Now, today's GIS also integrate the data from other sources, like there may be some ERP which is running in the city. So ERP, what they do, they are for the e-municipalities, ERPs. So this has a particular role to provide a governance. When you relate that governance aspect to the GIS, it gives you a different perspective of governing the cities. So this can be done using cloud computing, enterprise integration, shared services, open access. So you all know about the OGC compliances. So open access to any format, real-time tracking, so API-based integrations to the systems, advanced spatial, and on the basis of that, you can do on-fly spatial analytics of different types, and Geo AIs. Geo AIs are transforming the ways. Why and how it is transforming? In past, it was the major concern with the cities that how to update the data. So updating of data, like they used to do the property survey, and then they used to say, oh, I am so frustrated with that because I have already done the property tax survey in a 1 year. And now if I have to update that, again, I have to do a survey. So Geo AI has changed that terminology. It will provide you continuous set of data. There will be change detection on different models, and you can generate continuous data sets. So the things are changing now. So that is how a smart city will work. Then delivering it across the organization. Now it comes like we have integrated the data. Now there are different people who are working for a particular decision support system. Now GIS helps in that. Like there are field staffs who are working, like any disaster has happened or anything like today, this Viparjaya cyclone is coming. So there will be major field operations will be there. So field operations guy need to have a continuous input. So like events, any disaster, any operational efficiency issues are with respect to time. And time can be managed when you have a continuous tracking with mapping as well as the field operation. So it provides the information that this is the location with where you have to do what type of activities. It provides you analytical reports. There are data science aspects like how the data interrelated with the maps. There are different types of dashboards based on that. So entire organizational approach comes into. So that is why we call that enterprise GIS. Enterprise GIS is it working across the enterprise. It assimilates everyone's decision for a smart city. See, a smart city can be a smart city only if the people are smart. And people have to be made smart by providing the information and knowledge. And GIS is the best way to provide that information and knowledge through different sources. This is how the real-time visualization coming. So it helps in tracking, it helps in monitoring what are the things, and then alerting. So that is the workflow. It helps in alerting the things that, okay, there is a pipe breakage. So you need to immediately correct it. So that's how it works. So now the GIS maps and dashboards has become pervasive for any type of decision making. Now government is also realizing that, and this GIS based complete workflow. So once there was a term, even it was 5 years down the line also, GIS was not that much a high prior area for government or for students to learn. I have seen several universities where GIS courses were going vacant. But now it's the time, the AI has empowered it, the real-time sensors has empowered it, the continuous decision support system through drones, through high-resolution satellite image, through LiDAR has changed the way GIS used to be looked into. So now it is a continuous system and it has become pervasive. More so during the COVID time, the people had seen what is the power of GIS in decision making. So what GIS has done, continuous information from hospitals, it has been analyzed that how contact tracing is happening, which are the quarantine zones, and how to provide the medical facilities, how to provide the other facilities to people who are in need, who are in distress, how to manage and coordinate the assets. That is how it was shown that how a GIS can convert a control room into a war room when the situation of emergency comes up. Other use cases. So weather and air quality, today all of you know that we are continuously monitoring any type of weather activity, any type of climatic insurgencies we are working in. We are also monitoring the utility networks via SCADA. So it is for electricity, for telecom network, as well as for gas utilities, water, sewerage. All the SCADA network are providing them real-time information. Like in water supply, you know where the pressure drop is there. And accordingly, you can look into that, why this pressure drop is happening. So there may be some type of leakages or asset and entity tracking. So it is in terms of different mobility aspects. So where the ships are. So now, nowadays, you have seen all the metro station, they are giving you over the PIS that, okay, this metro is arriving at this particular time. It is expected time is given. So that is through GPS-based tracking. So over the railways also, now you can see where my train is, which is coming. So now you need not go to the railway station and spend your time there. Connected vehicles, so different types of vehicles are connected, and how that can be tracked. Complete FNG sector has been benefited through this technology of GIS. The infrastructure protections, which are the critical infrastructure in my cities and how to protect that. Personal tracking. And personal tracking means people who are very crucial for any type of operation, they can also be tracked using the GIS technology, and these are some of the use cases. This is another view, how it improves the operational efficiency. So you can see that any operation is happening. It may be for evacuation, it may be for any type of operations which are happening at a particular location. So you can track over real time how the things are moving from one point to other, which are the points of concern over that. So it can track vehicles, bus, train, metros. It helps during any type of events, and it improves planning and real-time decision support. You can track thousands of assets in motion. So we are now talking about integrated traffic management systems. So this can happen via tracking all the things which are in motion. So you can see, you can plan the last mile connectivities of any place. You can plan of TOD segments, transport-oriented development, by looking into what are the last mile connectivity, how the different sources of transport are integrated with each other. You can also improve the efficiency of fire vehicles, of solid waste trucks through this, and police patrolling, because to reach the nearest incidents of problem become important for police. So that type of trapping can happen. And then there are unlimited stationary sensors. These stationary sensors are, every electricity has some SCADA systems. There are smart meters in electricity, which are coming now, which are being forced, which are coming. So you can have the direct access to the meter readings. Now, no billman need to come and check your meters. It cannot be modified. It will be automatically going, and you can do a lot of analysis on the top of it using the GIS. It can track also the social media. So what the people are talking about the particular aspect, so you can track that on GIS also. That is very critical, because a smart city planning also should incorporate people's view, what they are talking about, what their problems are, and that is how it get mapped and tracked. And these are for the Internet of Things. So there are a large number of Internet things. There are cameras, there are environmental sensors, there are bin sensors, there are traffic emergency boxes, there is ITS system, there is CAD system, all this system together over GIS. So on GIS, you can have all those aspects together, and then you can take a decision based on what resources are working. And then you can also do real-time processing of those big data. So all these data, which are the trillion bytes of data which are coming from all the sensors, you can do a real-time analysis, which are the hotspots, which are the location where the problems are, so that you can adopt the decision accordingly. Like for example, if I tell you, you might be aware of that all the smart cities are having pollution sensors at different locations. What is good to look into that okay, these pollution sensors say this is the NO2, this is the SO2. It actually don't mean anything for a common man. It can be important to put that data. You have to create the complete contours of pollution, and then you need to analyze which are the sink area and which are the divergence areas of pollution. Then you have to interrelate that with the vehicular traffic. You can interrelate with the people's density, that if the pollution level is high for particular, so suspended particle is high, so how it is going to impact the people's heart conditions or people with asthma. So that is the power of geoanalytics, and that is the use of the environmental center. Otherwise, if you see that okay, SO2 level is this and NO2 level is this, so that does not carry any meaning for a common man. Common man is only concerned about how it is impacting. So that impact can be generated through GIS. These are operational dashboards. As I told you, the real time, what are the things that are happening? Any movement, anything, any gauges that can be looked into with the data, that where the pressure drops are, where the electricity faults are coming up, where the telecom network is dropping. So that types helps in immediate decision making. And as I told you, it's the operational efficiency from field to the executive level. Today, why we are unable to take any decision? Because we don't have this collaborative approach from field to the executive level. GIS help you to do that. So it creates a operation and maintenance plan. You can execute that, you can review that. So that is how it works. Everything on a cloud technology. Now cloud is coming up, and GIS has to be on cloud for taking this operational efficiency in a very fast mode. These are some of the data stories. So as I was mentioning, that it is very essential to know how much is the telecom strength at a particular point. So Airtel is using this simple app to see what are the real-time coverages of the open network. So they are using the GIS fully to see what is the signal, which are the existing towers, and how much is the signal strength, where what type of coverages are there, where it is moderate, where it is good, and where it is excellent. So that they can improve their coverage and they can improve their strength of network. Again, Geo is also using this type of system. So you can see that real time they can look into each and every aspect. So telecom was one of the areas which were prime in using the GIS technology for their complete asset mapping. Because why more so in telecom? Because they were privatized. They are privatized, their entire business depends upon their efficiency, that how they are catering to the people, how the network is coming for the people. So they have to use this technology. Now electricity are coming up when they have been privatized. So now electricity is also all these electricity companies are also looking for GIS to understand where what type of load is there, where the load faults are happening. So when this criticality comes, then GIS becomes very, very important. Cyclone tracking, where the cyclone directions are, how that is moving, what is the strength, what is the expected time when it is arriving, so that we can plan the disaster management. So that is a real-time operation. These are the COVID cases, as I have mentioned you, real time for every city. This is for the National Disaster Management Authority. They have taken it for the entire country, that in which states the cases are increasing, so that they can provide some support to those states. You are aware that time special grants were given to the states to manage, to control that. Resource allocations were done. So where you don't have doctors, the doctors were pushed into those sites. Where the oxygen is less. So oxygen balancing in the entire country has happened based on the GIS maps only. That where the number of patients are requiring, how much is current oxygen supply in those cities. It is based on this decision that everything was managed. These are few other cases, like in Florida, they are mapping the different types of operational assets like supply tanks, wells, and plants, so that they can see that how the water supply is equitably distributed inside any city. Another example of water utilities, how many distress calls are requested from each area regarding water for sewer, and then how much time they have taken in addressing that, so that you know which are the distress points where the network needs urgent maintenance. Asset risk coefficient, as I was mentioning, where from the more distress calls are coming up. So you can create an asset risk level based on that. So which are the primary areas where the asset risks are more. You have to identify those areas, because asset management is the most important component of a municipal corporation or municipal body in the country. So they need to look, they need to prioritize their spending. And when asset risk management is done, then they know how to plan for that. Transport segment, you can apply different types of. New York has integrated that for the traffic. The cameras are collecting for the real-time information on collision, and the pedestrian movement, cycle movement, everything is correlated through these cameras. They can look into how the different modes of transport are working. This is another example. Today, you know that all the cities are providing these ANPR cameras. So these ANPR cameras are capturing the day and night, they are capturing the vehicles over the road. So that can be this, the shape of each car can be integrated, that what is the multimodal system of transport on a road, on a junction, and how then the traffic can be planned in a better way. Which are the points of traffic congestion. You can see in the bottom that they can identify which are the points of congestion, which are the problems of traffic problem, which are the points of accidents that can be captured when you do this type of analytics. And these are big data analytics. This is for accident. Columbus have applied this. They have tried to identify which are the points where what type of injuries are happening. They have tried to check it, that is it because of the faulty road design, or is it because of the traffic, or is it because of the volume by capacity ratio of the roads. So that type of analysis can be undertaken when you have a lot of GIS data for that perspective. And the data, as you see, are updated every week for decision making. For safety, as I told you, this is one example of street light. So you know that crimes happen mostly in those areas where the traffic lights are faulty. So which are the dark areas in the city, there that people get more courage to do any type of theft or any type of other crimes. So a simple application. Yeah.
Excuse me, madam.
Yeah.
5 minutes are remaining.
Yeah, sure. I will complete
Yes.
in that. So this is a simple application that which it is being associated with the crowdsourcing app that they have provided, that this traffic problem, traffic lights are not working. And then also again, they have classified into 3 parts. So green dot is okay, the ticket has been raised. Yellow dot is that that has been analyzed in the first step. So if it is only a matter of changing the bulb, it is only a yellow tick. But suppose there is a major problem in the entire network, so that has been put into red color. That here the issue is different. They have addressed the traffic signal people has traffic poles has been addressed, but the problem is something different. So that type of operational efficiencies can come up. This is flood hazard mapping over the digital elevation model. As we know that urban flooding has become very common with the climate change issues. It is becoming more aggravated, especially in the coastal cities. So that type of flood mapping, so that we know which are the critical infrastructure which are in trouble, which are the vulnerable population who are in trouble because of the floods in the cities. Crime analysis, what types of crime happening in which part. You can analyze that this is the part where the crimes are happening mostly. So the decision in terms of increasing the patrolling vehicles, increasing the police station, looking into what types of problems are happening and why it is happening, what types of crime are there. So different types of hotspots can be generated. Economic aspect. So when we are talking about the smart city, economic aspects are also to be considered. So why GIS is very important for that? It's a growing market. It is an intelligent world we are living in. So where my markets are, where my raw materials are, where my manpowers are, where the finances are available, which are the creating export base, all this need locational intelligence. And that's how it helps. There are examples where the city, the Oakland County has looked into how the job creation, which are the new emerging businesses which are coming up in the city. So you know that we are living in the world of startup revolution. So which are the startups? How they can get the funding? How many jobs they have created? If that is being mapped, this is going to give a lot of boost to our market segments. See the figures, $5.4 billion. This initiatives has helped in increasing the things. 95,000 jobs. So that is how in the financial market also GIS plays a very important role. You can also generate the 3D. As Kiran has also pointed out, through drones and all, you can generate the 3D. You can generate the 3D informations as such, that how financially they are growing over a time period, how the land values are increasing. So that type of aspect can be mapped in 3D. Manufacturing map tool. So where the manufacturing companies are, how that can be clusterized. So you can see that These are the manufacturing clusters and what are the ancillary industries, how far they have to travel. If it is a food industry where the cold storage facilities need to be provided, food is a perishable item, so how transport things can be provided. So all this can be done only when we are using the GIS for the information system. And last, digital twins. Okay, so digital twins, this is about the Shanghai city. So drone maps, a virtual city was created. Then every aspect in it was mapped. So every transport infrastructure, how they are connected has been mapped. Then the simulation of the city. So simulation in the terms that you have to adopt different methodologies to convert the GIS data to 3D information model. And this, see, they are changing that into a complete information model. Then this is the drone survey paths and all, which has been by the continuous updated from sensors. So it need a continuous updation also. The sensors help in converting these 3D informations. These are some type of complaints which can come up, like there is some complaints of infrastructure. So in 3D, you can see that on from which floor it is coming up. All the building informations are attached to it. Monitor the traffic flows. Citizens' opinion. So all this together and create an impact zone of any decision making. So that is how a 3D city can work. And that's an end to my presentation.
Thank you so much, madam, for this elaborate PPT and covering all the key aspects of a smart city. Now I request our next speaker, Mr. Shashank Mathur, Hexagon, to deliver his presentation.
Hello.
Yes. Hello, sir.
Thank you, sir. Yeah. So I'm audible.
Yeah, you are audible.
Yeah. Let me share my screen.
Yeah. Sure, sir.
Can you see my screen now? Hello. Can you see my screen now?
Yes, it's visible.
Yes, sir.
Okay, great. So I'm Shashank Mathur from Hexagon. So today we are going to talk about the various application of the GIS, how GIS is being used for in the smart city for various use cases. So today in this session, I'm going to cover the how you can manage the traffic, how GIS can help you to analyze the impact of noise pollution, how you can plan the CCTV location for their best coverages, and how you can utilize GIS for city planning and for citizen-centric services. Also, the public health management, we will cover the infrastructure planning and monitoring green spaces, the flood impact analysis. So those applications we will cover using the geospatial technology. So like in a traffic management, smart traffic management, basically we are getting the data, traffic data.
Sorry, sir, I think interrupt you. The screen is not clear.
The screen is not clear.
Yeah.
Okay, let me share my screen again. Can you see my screen now?
No, as it is.
What to do? Yeah, now I think I should. Now, can you see?
Yes, that's clear.
Okay, great. Should I repeat this? Let me once again repeat this. What all applications we are going to see today using the geospatial technology. So, like smart traffic management, how you are managing the traffic and all using the geospatial technology. how GIS is useful or providing the analysis or impact analysis of noise pollution, how the GIS is useful for identifying the best location for the CCTV cameras for their best coverages, how the GIS is useful for city planning, citizen-centric services, public health management, city infrastructure planning and monitoring, monitoring and managing your green space, and the flood impact analysis. So let's start with the smart city, smart traffic management. So can you see my this screen? So with the we are getting the information of the traffic from various sources like sensors and all. So we are integrating that data with the geospatial maps, and then we have overlaid that we are overlaying those traffic volume information on top of the drone data, the satellite images, or various kind of base maps. So you can see that, okay, where the density of the traffic is more and which time the traffic is more in which area. So all those analysis you can perform in a dashboard kind of scenario for your better decision making. Now you can, let's say you want to investigate for the accident prone area, or if accidents happen there, so you want to further investigate that why the accident has happened and why how you can mitigate that problems at a particular intersection. So you can recreate the scene using the point cloud data, using the drone data, or using the 3D models. So from various sources, you can recreate that scene, and you can further investigate that, okay, how it is it has happened, and then you can further investigate by measuring the different type of dimensions, the heights and all. So if you see in this video, you can measure in the 3 dimension. You can recreate the scene here like this. Okay. Now let's move to the different slide for noise pollution impact. So in cities, we have the metro trains, we have the various vehicle movement and all. So how we can plan our city accordingly, that the area which is less noise pollution can be planned accordingly, and how we can mitigate that pollution. So here you can see this is the use case of the metro line, where it is showing the impact, the different type of impact, the high impact of the noise, the moderate and the low impact of the noise, and the surrounding buildings, where you can see that, okay, if the building, you can plan your buildings that where it should be situated and what should be the valuation of the building. All those things you can decide here using these kind of analysis. Correct. So if you see here, you can see the moving underground, overground trains and the metro trains, and the circular motion in the circular or spherical dome in a different color. So red is basically the more impact, yellow is the moderate one, then green is the less impacted area. Okay. In city planning, so you have the 3D model, the digital reality model of the city, and then with that model, if you, let's say, want to plan a new building or some township or anything, so you can plan in 3D. So it will basically help you to, let's say, if I want to position this particular building at a particular place, so how much it will impact, what impact it will give you to the adjacent buildings. Let's say it is obstructing the sunlight, or what is the shadow casting of that building on the other building. So if it is obstructing the sunlight, the valuation of the adjacent buildings will be less. So, like you may have heard about the example of in Noida. There is there are super tech towers, the twin towers, which has to be demolished because of this reason. So, if we have the proper planning, so we can mitigate those kind of problems. We can overcome those kind of problems. So, if you see here, you can move the buildings, you can place the building at appropriate location, you can define the height of the building and everything you can define here, right? Then again, coming to the CCTV coverage planning. In CCTV coverage planning, basically, you have the 3D model, the digital reality model of the entire city. Let's say you want to find out the best suitable location of the CCTV camera. So here, if you place the camera dynamically, it will show you that, okay, what all area are dead zone and what all area is visible. So you can decide based on that dynamic visibility analysis, you can decide that which is the best position for the to install the CCTV cameras. So in this video, you can place at any height or any location, and you can perform that visibility analysis. So I will again play this. So if you see this red portion, this is red zone. So if I place this CCTV here, this the red zone will be more. So this is not a suitable location. So we can change the height, we can change the location to cover the entire area of this by the CCTV. Coming to the citizen-centric mobile app. Connect the login screen. Click on employee login. Enter username, register email ID, and so here in citizen-centric service, these are basically the mobile app-based geospatial platform where the citizens can, along with the location, can register their grievances, and it will go to that the centralized location and command and control center, and the team will be sent to that location to address these problems. So there are these mobile application for different type of use cases, can be for the sewerage or waste management, for any type of like pole light is not working, or any type of problem in the ULB area. Coming to the public health management. In public health management, using the GIS map, you can overlay the various type of wards, various type of zone boundary, the ward boundary, hospital information, the citizen information, their locations. Those things you can overlay there. With the hospital information, you can also integrate the information like how many beds it has, what all facilities it has. So those information you can attach to it, and then in case of any outbreak of disease like malaria or any type of disease, you can find out, you can plan your resources accordingly, that or if needed, how you can if needed, how the resources can need to be new resources need to be built, or something like that. So you can do that, right? Coming to the infrastructure planning. So in infrastructure planning, again, there are various type of infrastructure, mainly the utility network, the water utility, the sewerage and all. So how you plan it? So along with the GIS map, you can overlay the various type of ward boundaries, the residential areas, the commercial areas, their demand of water. Let's say this example is water for water utility. So you can overlay the demand of water, that how much water is required for a particular ward, and what is the current supply, and how you can increase that supply. Let's say you want to construct some new resources. You want to construct some water tank, you want to lay some new water pipelines. So those things the GIS will assist in planning for those things, that what location, which location to be the suitable, which are the suitable location to be placed for those type of resources. Now coming to the infrastructure monitoring. So like I said, the infrastructure like the water utility, the sewerage network, various type of network are there. These networks are underground also. So with that, see in the ground there is a, because of the heavy rainfall, because of the seismic activity, or because of the mining activity adjacent to that township or adjacent to that area, there might be some subsidence, and because of subsidence in the ground, these underground utility lines can be impacted. So this information, basically we are using the synthetic aperture radar data to identify the subsidence of subsidence areas, and where the more subsidence, the utility is most impacted. So we have highlighted those utilities in red, green, and yellow color. So red is most impacted utility, and then we can take the preventive measures, that how we can provide information or to provide the solution to mitigate that problem. Okay. Coming to the green space monitoring, so for most of the utilities, basically they have to maintain their green cover. So to maintain their green cover, they have to know how many trees are planted, how many trees are there in that ULB area. So there are mobile application for the surveyors, for the citizens to collect that information. So surveyors will collect that information and create the census of the tree, that how many tree ward wise, the zone wise, and entire city, how many trees are there. And citizens can can request for, if let's say citizens has to extend their house, extend their building, or some modifications in their house or in their building. So they, let's say for example, they want to cut the branch of the tree, they cut the entire tree, so they have to take the request from the municipal corporation or the ULBs. So so both type of mobile application they can use, the either by the citizen or by the surveyor, to collect the information from the tree, and citizens can make a request using the mobile application for tree cutting. Now, once they make a request for the tree cutting, then the ULB can go to the portal, and then they can identify that, okay, ward wise, how many trees are there. They have the entire information. They can search the information, they can search the number of trees in a particular ward. They can perform various special GIS-based queries here. Even they can also find the trees based on the species, and then they can also integrate some BI analytics, like the pie chart, the bar chart, the row chart. All those analytics they can integrate here, and then they can analyze the green cover in their area. So even let's say if there is a tree cutting request from the citizen, that the approval process will be and there is a workflow where the authorized person will log into that portal. They will go, they will check whether this tree can be cut or not, or branch of the tree can be cut or not, and based on that decision they will give the approval for the tree cutting. So here in this, you can generate various kind of reports. You can integrate the pie charts, the BI analytics, the various type of, and then you can take the plot also. Okay. Coming to the flood impact analysis, in flood impact analysis, the post and pre-flood impact analysis. So you using the drone data, using the satellite images, you can do that. But when you overlay that information, the flooded, the inundated area information on along with your the buildings and along with your assets, so you can find out that how much the assets or the buildings or any structure is impacted, and you can also find out that okay, how much compensation to be given to a particular owner or to the particular in case of agriculture field, it can be farmer. In case of building, it can be a building owner, or how much compensation to be. You can decide based on the impact by the flood or by any this kind of problems. So with this, I would like to end my slides, my presentation. Thank you so much. If there is any question, please let us know. Otherwise, we can discuss at the end of this meeting.
Thank you, Shashankji, for your presentation. As you have completed before time, we have 10 minutes. So I request audience to ask questions to Shashankji and Rumaji also, if you have any question. Hello, anybody, if you have any question, please ask.
Satish, in interest of time, we are going to take all the question and answers towards the end. So if that's okay, we can move ahead with the next presentation.
Sure, no problem.
Yeah,
no
thank
problem.
you.
So our next presenter is Mr. Yatendra Singh from Satpalda. I request him to deliver his presentation.
Okay, so is my screen and presentation is visible to all of you? Hello.
Yes.
Okay, so hi, so welcome to all of you. So this presentation. Okay, so this presentation is going to be about role of VHR to HR, that is very high resolution satellite imagery, terrain data sets, and 3D building models in smart city projects. So I'm not only going to show you presentation, but I'm also going to show you a demonstration of platform that will help us knowing that how fast we can access to satellite images. So as we know that with the pace of urbanization is speeding up, with an expectation that we are going to have better facilities and living condition. A very few years back, we saw that Ministry of Urbanization Development, they launched and they initiated a very much laudable national program called as Smart City in India, so that we can match with the pace of urbanization and derive economic development. So when I say smart city, it's not only about using technology for the services and solving city problems, but it is also about adding value to the life. So when I talk about smart city, we are talking about getting information quickly and when required, wherever we are, whenever we want. So we get access to the data not only near real time, but also real time. So this presentation, I'm going to focus about how fast we can get satellite imagery without getting involved with a third party or without getting involved with the operator, right? So for that, I'll show you Spectra AI platform after that. So with that, what I want to say is that the blend of technology and the master data set when get accessible to the decision maker in the publics, they can respond to anything that unfolds in the ground as soon as possible. So overall, it's about positive impact of the technology and adding value to the life. So coming to the implementation of the objectives, we have some strategies like retrofitting, greenfield, redevelopment, and smart city planning and design. So when when we talk about pollutions and greenhouse emission, we mostly blame transportation. We start imagining, hey, yeah, like a large number of vehicles stuck in a traffic jam. But buildings is something that has contributed more to the pollution comparatively. So retrofitting is required in old building like this, so that there is an improvement of durability, and it also helps lesser emission of greenhouse gases. So most of the time we have heard that whenever temperature rises in Delhi, so construction works are standard, so that because there are a lot of GHG, that is greenhouse gases, are emitted from these construction. Coming to the and how do we do that? See, GIS along with BIM and lesser scanning, it plays a vital role in retrofitting of the buildings. Okay, so next strategy is greenfield. So I'll give you a very good example of this particular strategy, that is greenfield. So right now we are working, we are monitoring this Noida International Airport, that is Jewar Airport. So this airport is like it is getting constructed in a very large field and in a very isolated area. So what if we started just digging up and just start constructing this Noida International Airport without having any planning? So we are monitoring this particular area with the help of satellite imagery on quarterly basis. So once the data is acquired, high resolution data is acquired, we assemble all the geospatial and non-geospatial data set in the same platform. Then we calculate the green area cover, and then we determine the accessibility of that particular area, right? Coming to a third strategy, that is redevelopment. So GIS, obviously, it helps us to identify and select the most suitable brownfield site for the redevelopment and for the housing. So if the site is contaminated, its statistics can be studied with the GIS data sets, and it can help us taking decisions about that particular site. So GIS helps not only understanding natural and physical, but also socio-economical relationship of the brownfield site. Smart city planning and designing, GIS help in construction. This I think already have been covered by in the previous lecture, that how GIS can help in construction urban digital model. And coming to the approach, that how do we approach these particular objectives and strategies? So urban digital model, which includes DSM, DTEM, and DEM, and coming to the data collection, which demonstration I'm going to give later. So as soon as the data is acquired, we can have the intelligence report, and we can see that what exactly is happening in that particular AOI, and it can help us understand the pattern of life. So we visualize the data more interactively, data compatibility, and spatial decision support system, that is SDSS. Okay, high resolution satellite imagery. So you see, currently we are shifting from static world to the more dynamic world, which means that we are not doing static mapping anymore. We are doing that, but it's very common. So currently we are shifting from more dynamic view of the world. So acquisition of data is not a challenge. Challenge comes when the customer or the when client requires data as soon as possible. So when I say as soon as possible, it means that within 15 minutes, within 90 minutes. So it's a challenge, it's a challenge in this particular era, that you get satellite imagery in this, in quick time. So when you get this imagery, you can respond to all these things that unfolds into the ground, that is disaster. So for example, if you get the imagery as soon as possible, you can inform the responders, and responders can arrange the team and send help as soon as possible, and they can make all the planning model and see the availability of the road and all that. Coming to the terrain data, so once you have DTM, DEM, and DSM, you can you get the knowledge, you get the information that what kind of geomorphology that particular terrain is having. You can have the slope analysis, and you can extract the feature which is natural and which is human made. So with that, you can do surface water mapping, you can make the drainage planning, you can do the inundation level during flooding also. So this is how the 3D building looks like. So this, this is a sample of like Palm Jumeirah that we have done. Okay, coming to the, okay, now, so these all things that I discussed, they were the things that were above the ground. Now, what about the things that are under the ground? So it can be like water, it can be like water pipelines, power, fiber optics, drainage, sewage, gas and telecommunication, like, and etc. So, what if we go without any planning and we start digging up all these things? So like we are not only doing exploitation, we are doing over exploitation of this particular area. We're not only giving risk to the third party that has already installed things in that particular ground, but we are also making things difficult for us to make the plan to get the things where we want, okay, without having any planning. So GPR is the tool which sends the radio signals down to the ground and create an image of the features that are below the surface. And solid waste management. So waste management, we know that it has become a very tough task for many cities around the world. Why? Because due to the significant increase in waste generation because of population growth and combined with technological advancement. So once you identify data related to waste management, once you get the record of the waste bin, and once you identify the pre-existing waste disposal pattern, it becomes very easy for you to locate optimal waste dumping zone, and you can maintain the record about the amount of waste that is being dumped at the landfill site. Right. So now I'll show you a demonstration of the platform that which will get you idea that how fast we can get access to the data whenever we want and wherever we are. So I think this particular portal is visible to all of you. Is it? Hello?
Yes, sir.
So is it, can you see the portal Spectra tasking?
Yes, it is.
Okay. Okay. Suppose I'll go to any one of area. And suppose I want and suppose if any activity unfolds over here, like any area, like this particular platform is having global coverage, so you can take satellite imagery of any particular area, any area that is of your interest. So I'll go to new collection, right? And suppose if I want to see that what has happened in this particular area yesterday or earlier in the morning, or what can happen in this particular area in the evening. So we give you data in a very low latency. If you say that what about the imagery, what about the fresh imagery, then this fresh imagery can get acquired within 90 minutes. So it will get delivered to your dashboard within 90 minutes, and archive imagery, that is the historical data, get delivered to you within 5 minutes. So I'll show you how to do tasking and how to see the live satellite of the passes any area. So suppose if I'm more interested to see that what exactly is going to be the situation in this particular area in the coming evening, in the evening of this day. So I'll just drop this pin over here and I'll name it as test. And then I'm going to schedule the collection date range. So how long do I want to monitor this particular area? For the next 14 days, for the next 7 days, or for the next 20 days? Let's say I'll go for the next 14 days. I'll save and I'll choose the frequency. For the next 7 days, I want to monitor this particular area for once per day, once per week, or maybe I'll go for the all available opportunities, so that as many as satellite passes, I want imagery to be captured by as many as satellite passes. So I'll go for all available opportunities. So once I do that, I'll see visibility of this particular area, which shows you the live passes of the satellite. So these green balls, these all are the opportunity that will get in this particular area. So if I click in any one of these balls, I'll go to global 16, and this will show you, not only show me date, but also time, that at what particular time your data will get acquired. Suppose it shows that 2:48, it's showing that 16. Tomorrow this data is going to get collected. So you see 1, 2, 3, 5 satellites, five opportunity you are having in this particular area. So 5 satellites, 5 live passes of the satellite are here for tomorrow, right? And if you click on any one of these green balls, you'll see that will show you date and time. So once the data get acquired, it will get delivered to you to your dashboard within 90 minutes. So same thing you can do with with any particular area, anywhere in the world, right? Coming to the what product we have, like we have standard, that is a very standard satellite imagery. Also we are having area coverage, that means if your area is larger, if your smart city is like larger and you want to monitor this smart city on daily basis, so you can go for the area coverage, that is 2 times of the standard. Stereo is for the 3D visualization of your city, by which you can create DSM, terrain models. So these all are automatically derived products that you will get delivered, and you don't need to have any expertise in GIS, and you don't need to go to the operator and ask him to acquire images for you. Once you get this platform, once you have this platform and you have login credentials, you can command the satellites. Like you are the boss, you are the one who's going to monitor this particular area. Who's going to command the satellites to acquire this particular area for you. And once the data get acquired, you'll get the notification, you'll get the alert, you'll get the email that yeah, your data is acquired, please download that. So you don't need to go to the operator and ask him to do auto rectification also, because if I show you, yesterday we have today we got this data delivered. So if I show you sample, that in what format and what deliverables we have for this particular area. So this is area. So this is the this particular area we are monitoring, where we'll install solar farms, and the client that we are doing for is Samsung. So if you see over here, you'll see that this is not only geo-referenced, but this is auto-rectified also. So as I told you, you don't need to have any GIS expertise, and you don't need to hire any GIS technical team, because your data is already auto-rectified. You just need to download it, like whatever format you want, in a zip in GeoTIFF or an ITF. You just download it and you start processing, and you start doing the analysis of this particular area. So no operator in between. This is totally software approach. You don't need to go to the operator and ask him to acquire images for you, because it takes like almost 3 to 4 days. Coming to this data get delivered to you within 90 minutes, right? And in the same platform, we not only have tasking, that is, we not only acquire fresh imageries, we also have archive. That is, if you want to see the historical data in this particular area, that do we have any historical data? So from the same platform, you can access it. So I'll draw this rectangle over here, and I'll see that for last how many days I want data of this particular area. So I'll go for, let's say, last 6 months, right? And I'll select my product. I want in standard format or I want in stereo format. Okay, I'll just go to apply. So these are the historical data that you have over this particular area. Okay, which shows you cloud cover, which also shows you resolution of this particular area. So once you're like, okay, so this is the image that I want to order, you just go to like this imagery, you go to click imagery, you add to the cart, and once you order this particular imagery, you get this imagery delivered to your dashboard within 5 minutes. So this is how low latency we are having. Like, as I say, that smart city is not only about using technology for the services, it is also about getting data as soon as possible, and as quickly as you want, like wherever you are and whenever you are, like everything is in your hand. So we give you like we give you that all the power of the satellites into the user hand, where you can customize it according to your needs and according to your geospatial needs. Okay, thank you. I'll end my presentation over here, a very short presentation. But it was about like data that we can see in not only in near real time, but also in real time. So thank you everyone. So
Thank you,
if you have
Yatendra.
any suggestion, if you have any queries or suggestion, you can feel free to ask.
Yes, actually, Yatendra, we will take the queries in the last session.
Okay, sure, no problem, sure.
Thank you for your elaborate PPT. And we are heading towards the last presentation of our webinar. So I request Mr. Shahrukh Wase from Oracle to give his presentation.
Hello, everyone. Thank you so much. I'll just share my screen. Please confirm if my screen is visible.
Yes.
Okay. So today's topic for discussion is 3D data model for smart cities. I'll be walking you through with a couple of use cases and how using the Oracle spatial capabilities, that how we can build, manage, and utilize the power of geospatial and build up smart cities and using the power of computation, right? This is a safe harbor statement. We usually keep it before we present anything. Okay, so the program agenda for today will be, I will be talking about the introduction about point cloud, then how we can use point cloud data, how we can create city models, how we can publish the data, linked data, and maintaining the city model with the Oracle infrastructure. I'll try to keep very short, crisp, and whatever the doubts and questions all of you have, you can ask me towards the end of the session. Right. So when we talk about the using the 3D data model, providing the in context to the geospatial, many business cases usually have economic viability, wherein you realize that the cost of 3D data collection has significantly gone down. I mean, not actually it has gone up, but this technology used to be something very new in the previous years. But over the period of time, usage of the changes and the change in the geospatial technology and change in the geospatial policy as well, accessibility of drone easily. Now the cost has actually gone down and the data collection has gone up, and it is not happening across everywhere, across not only we are talking about the Western countries, but we are talking about across the world, right? Now, when we are doing that, if you talk about like a project like Swamitva and Alpine and everything, so they're using the drone data, and 3D data is very much required, right? And these projects are very large scale data wherein you want to process. And at the end of the day, when we are talking about LiDAR data or we are talking about drone data, we are talking about humongous amount of data to be captured and extract the meaningful information out of it and delivering the exact use case for the usage so that it can be used. And wherein we are also looking forward that how it can help the local government, the local agencies and the government, and how it can also help the telco industry, utilities, public transportation, public safety, all of it, right? And moreover, the way things are being transitioning, right now what I see is that, I mean, majorly what we use, like for example, let's take an example of Google Maps. Right now we just use it for navigation and we see a 2D plane. In the coming years, we will be seeing 3D planes, and what I see and predict, and there are a lot of other things which is happening in terms of respect to 3D and smart cities, is that it is a very realistic example that whenever you go to any mall or any building, it becomes very difficult for a person to reach to a particular destination because it is not in 3D model, and we always used to have to ask someone, or maybe we have to navigate a 2D map which is present inside a mall or a building or anything. Right. So this has a huge importance, and again, 3D models is something that will help our smart cities to have a viable structure wherein all the facilities for the user is available for the users, and a better planning can be planned for a city. So all 3D model, or when we talk about the 3D data, point cloud data, it all starts with the acquisition. It is one of the case study wherein, airborne was used, mobile and terrestrial data collection has been used. For LiDAR point cloud, to keep it a little technical, since there are a lot of students also from CEPT University, so they must be going into the depth of it, and this is the time for learning. So I've kept it a little bit of technical as well, wherein the density is 4 to 20 points meter. Metadata is full wave and intensity and 3D characteristics, and this is basically a vegetation passing through the vegetation as well, right? And point cloud density is 100 meters, and grid is 2.5. Right. So when we talk about a 3D data model on LiDAR specifically, what is actually required is that there is a sensor, LiDAR sensor, which is scanning right on the top and capturing all X, Y, Z, and all the points are captured. With specifically when we talk about LiDAR is, we are talking about massive cloud data, because every second the light is being emitted on the ground and it is extracting all the point data, right? And the data is humongous. Since it is humongous, so the points are humongous, and you have to extract every the XYZ value from each and every point, right? Then obviously there are attribute, and then you get the whole full wave sample, and then data storage, and then you have to do pre-processing, data analysis there, data extraction will be there, filtration will be there, projection will be there, classification will be there, object recognition will be there, change detection. Obviously this is the platform that how over the period of time things has been changed in comparison to that. Derivation of secondary products, wherein we are talking of DM or DTSM, right? And data dissemination. Why a database is very much essential. For this particular case studies, it was used on cloud, and Oracle Cloud is basically free for students, and then you can also, all the students who are attending right now towards, and I'll also talk about a product called as Oracle Spatial Studio, wherein all students can start using that. It is available along with the database for using QuickGIS, and how you can utilize the power of database along with the massive data for computation, and then you can visualize 3D, 2D, or the raster data sets over the platform itself, right? Now, when we're talking about because the data is so huge and humongous, right? So data integration with other sources required. So online availability is there, georeference images are there, existing 3D data sets are there. So bringing them all to one platform is very much easy and at ease. And you can combine multiple technologies onto one platform, and you can combine them, and you can form a practical usable usage of all the data, which is making little bit of sense to all the data itself, right? And faster accessibility, because obviously when you carry out anything over the cloud, at the end of the day, what you get is the power of computation. You are not restricted to certain amount of limitation in respect to the graphic card, or maybe processing, or maybe multiple computation of the PCs, or the power of the computation in terms of the processes as well, right? And obviously at the end of the day, database, relational database has its own advantages over any other database, because at the end of the day, you want multiple users to have an access to it, use it, consume it, and there'll be a lot of users, right? Multiple people accessing the same data at multiple given point of time. So you require high computation. And at the end of the day, when we are talking about the 3D data set specifically, it is humongous and it is heavy to process and visualize and to use it and consume it. Now, when we talk about the whole infrastructure of the database, how it is laid down in Oracle database, you get the deployable services like mapping, geocoding, routing, web mapping services, and obviously all the data, the GIS data points are being encaptured and encapsulated inside it, wherein we're talking about point, line, polygons, or geo-tracking, or network data sets, or maybe RFID graphs or property graphs or topology or 3D data set or raster data sets precisely, right? So this is the whole component or the infrastructure of the whole database that allows you to utilize all of it. And now assume that this all is on cloud, and you get all the capabilities of cloud and other solutions all together, and then the possibilities become limitless, right? So when we are talking about specifically in terms of Oracle, if we talk about the database is stored in SDO geometry for the benefit of the crowd. You know that when we are talking about ESRI technology, then they have altogether different geometry. When we're talking about Postgres, they have a different geometry. When we're talking about Oracle, we are talking about a different geometry. So the geometry that is being stored for Oracle is SDO, right? So geometry, this is basically a logical structure and a physical structure. When you see that this is point data is one image, one PC is like one image. But then at the end of the day, to make it more robust, more accessible, we break the whole PCs into blocks so that it is accessible. I give you an example. For example, you're working on a Delhi region, right? And you want to, let's suppose you're working on Delhi NCR region, and you just want to focus on Delhi, and then probably you want to focus on the block level. The rest of the other things are not being utilized at the same time. This will allow you to have an access to block level. That's how the implementation has been, so that the data transition and data accessibility becomes much more faster, easier, and streamlined in a way that there is no lack while we are doing, or even the real-time updation is happening inside the table, right? So this is the whole 3D process workflow, that how it has been achieved and how it has been done. The LiDAR file has gone into it, into the load structure. All the points has been extracted, right? And even the flat files which are related to the 3D data sets, right? And they are combined into creating a tin. And we have done a query on top of it, then extracting the elevation contour lines, geometric buildings. Then also you can extract the change detection, distribution, data confrontation, viewing, wherein we are talking about pyramiding. Pyramid here is basically when you have a humongous data and you want to zoom in, you have to build pyramid, so that whenever the user is basically utilizing or consuming the data, it becomes much more easier for the user to consume the data without any lag. That's why the pyramid is required, right? For viewing purpose and obviously classification. And then this can be further converted into geometries. Then you extract a tin table out of it, generate DEMs or raster DEMs, right? That's how basically you can, and then further, then you can also project it into a 2D geometry or tin, and then further you can also query it and convert into geometries, right? So this is the 3D processing workflow that has been used in the couple of case studies that I will be discussing further. For visualization purpose, in one of the case studies wherein Luciad was used as a product to utilize, and this is the cloud data. This is how a LiDAR data looks like when you are trying to capture and visualize it, the point cloud data, right? And as you can see, as I was saying, that when a LiDAR is, when you fly a LiDAR flight, you get a lot of points, and you see here there are infinite points, and you have to extract the usual information out of each and every point. And when we're talking about the smallest area, even there are humongous amount of points that are captured. Modeling the CTGML, right? So using the data required objects, wherein modeling required for any kind of analysis beyond visualization, associating the objects with geometries and topologies and semantics and appearances. CityGML is established standard. Basically, it's a standard format that is used for city purposes only. That can be used, which has a specific model, right, representing a 3D or urban object, defining the classes and relations for these objects. XML-based formats are exchanged and stored in GML. It is again a format here, right? And it has been standardized by OGC. OGC is Open Geospatial Consortium, so it has been standardized with that. The current version that was used for this particular case study was 2.0, right? Now, there was also an open source data model that was used, which the reason was that it was a semantically rich, hierarchically well-structured model. It has levels that can talk about, because when we're talking about 3D data modeling, irrespective to the building, what is more important is that you get the right facade, you get the right texture. So every building has its own structure, texture and facades, and the way building has been designed. All buildings are, so those kind of attributes are very much essential and required for any kind of 3D data modeling, right? So you need to have those kind of information, and then only probably, and then replication of the same kind of studies, replication of same kind of buildings, right? That is also very much required, right? And when we're talking about this, so the management of aerial photography using SDO raster geometry, this is again geometry that was used inside the database that can utilize the geometry. Whatever you store as raster or georaster is stored as SDO georaster in Oracle. So this is city of Frankfurt, where mainly Germany, right? It is a city model that has been developed based on the LiDAR data, building footprints and cascades. Buildings are the LiDAR data set is D1 and D2, and facades are from obliques and aerial images. So both of them, if you are able to recall my previous city data model, right? As you can see, there was a flat file was coming in, and the LiDAR data was coming in, and other things. So multiple things has been combined together to form a model that has helped to extract this beautiful structure that you see at the moment, or the image. This has been used, right? And all the data was held inside the database wherein it has been exported. So CityGML is an API which is available. 3D FX is also, and Shape 3D. So these are APIs that can be consumed, and you can Google about them, and you can read about them, and you can use and you can utilize that, how you can also utilize it inside, right? Now, publishing a city model as a linked open data, wherein we are talking about that how we can publish it, how user can consume it, and how they can query on top of it. So when we are talking about this, so the metadata is very much important, and all this has to move towards the AI, right? And using the common vocabulary. So while we are publishing all this, as you being the user, one should always think about it, because let's suppose today, these are the example of the West, right? But when we are doing it, let's suppose for India is altogether very different, structured GIS data, and till date, even let me just give you an example precisely. I have recently shifted to Noida, right? And the pin codes are also changing of the region, right? And even today also, and Noida being little structured in comparison, in comparative to Delhi, or let's suppose see a well-planned and then structured city is Chandigarh, or maybe let's see Bhopal or Madhya Pradesh, or other cities like Pune, or maybe so even in those scenarios as well, still we are demarcating, or we are have a reference location to the location, right? Still it is not structured in a way, and this will be there. Hence we need to think about the common vocabulary as well, so that it can help us to find the exact location. and it helps us to build the 3D data model, right? And obviously W3C standards are very much required whenever you are doing. So these are the parameters that has to go in. We have to maintain those standards, right? And logical reasoning to classify features like land cover type, suitable farmland, etc., in combination with these spatial queries. The key capabilities for GIS and in specifically in BIM, because at the end of the day, when we're talking about smart cities, it has to be integrated with BIM, right? So this is also another architecture. If you see that the data is stored in the database, and then there are RDF graph layers, then the graph management, query engine, ontologies, inferencing engine, and all this is combined with graphs, analysis, report, queries, and all the things. And this all comes down to AI/ML as well as the modeling of whole. Whenever you are basically designing a smart city, there are infinite parameters that has to go in, right? And whenever we are talking about smart cities and designing of them, these parameters are from the ground level to the upper level, wherein you have to consider lot of parameters like the road structure, the environmental structure, the building structure, the green and the building ratios, the utilities, right? The transportation, right? So all these things has to come, and it has to form in a form of a structure wherein you think of a smart cities when there's absolute zero problem in terms of serving to the citizens of that particular city. Now, this is also one of the structure, one of the use cases, right? Maintaining, when you talk about maintaining, right? How you will do that? If in case you want to maintain, now you have developed a structure and you want to maintain it. So there has to be a classification and change detection. There has been changes, right? If you see the current image right now, there are new classification and the change detection. So there is difference, right? Both difference has to be evaluated with the data model, and that evaluation will give you the latest city model. It is simple as let's suppose there has been change in the equation. So simple plus minus will help you to solve those equations. Another change detection process, right? This is a point cloud classification, one of the screenshot, right? Once when you run the model, let's suppose this was the initial one, and then we run the model, we extract the building footprints. So this is the classification, how you can see that it has extracted all the building footprints, and you can clearly see the vegetation, the open area, and the buildings, right? And this is the change detection. Once you subtract both the images, the previous one and the one that you have extracted, how over the period of time things have been changed. Once you do that, it is referred to the same model that I was referring to here, right? This one. So the new is there, outdated is there, and up to date is going to be a combined image. Either a new building is formed, or either there has been changes in the building, or there has been change in the grassland on the open area or the closed area, right? So likewise, this is again one of another example wherein maintenance of the 3D smart city models, wherein let's suppose the city was like this, and then you want to maintain it, and then over the period of time the urban sprawl has gone up, or the number of the settlement has gone up, right? And you can bring in more. So the model can be maintained, and in a way that it keeps on updating, because you have the continuous data coming in, and then you keep on updating the data itself. For infrastructure, I just thought if in case, anyone would want to get into the depths of it. So this was Octa CPUs that was used approximately for this particular use case. For this particular model, there were like 28 Octa CPU were used to NVIDIA Tesla P100 graphic card was used. Simple setup and maintenance, and network connectivity was somewhere around like. So this is all on the Oracle cloud infrastructure that was used for creating these particular case studies that I am showcasing you at the moment. Right. So as I was saying, 3D data model can be, managing them with Oracle Spatial and Graph database. You get the access of the 3D live data visualization and analysis, integration manager of any kind of 2D and 3D data, on-site processing because it is there on the cloud, right? Management and publishing of the data and metadata, making the data usable through the open standard and taking the advantage of the cost effectiveness of the database and functionality. Obviously, everything is since there on the cloud. Before this, I would want to show you people something. So this is when we are talking about, many of you know Oracle is just the database, but this is Oracle Spatial Studio, which is available for everyone. You can download it from Oracle website. And you can use it. And since there are a lot of students here at the moment, Oracle has Oracle Cloud Infrastructure certification, which is running at the moment from Oracle, which is free of cost. So I would request all the students, it's a great learning to learn, and you can go onto the Oracle website and you can enroll yourself for the certification, and you can also get certified on the Oracle infrastructure certification, right, on the cloud itself, for the cloud offerings. So this is a very small. Hello. Hello. Can you please go on mute? Am I audible?
Yes.
Am I audible?
Yeah.
Okay.
Yes,
Okay.
yes, yes.
Okay.
Yes, sir. Yes, sir.
Yeah. Okay. So this is Oracle Spatial Studio, which you can download, all of you, right? Especially for the students. Rajwal, yeah. So this is Oracle Spatial Studio that you can install and utilize, and this is for quick GIS and viewability. This has an access to all the data that has been stored in the database itself, and you can that you can basically pull, and you can visualize and utilize and use inside it. So all the data, for example, you have been storing the data in the Oracle database and you want to visualize all the geospatial data. You just need to have this tool, which is freely downloadable. You download it and deploy it, and you consume all the raster, vector, 3D, everything that you want to visualize it, and you can visualize it here itself. It's a very simple, easy tool, right? You can see that there's a project that has been created for 3D data, 3D models, right? And it has a lot of geospatial analysis tool as well. Let me just go. Okay, let me just open one of the projects for you people. So as you can see, this is the data of the submarine that is coming in here, and it is coming from the data set, right? And you can do the spatial analysis on top of it, whatever data you have, and on the fly you get all these kind of geospatial queries that you get, and you can consume on the fly itself, and this all will be stored directly on the database as well. Right. I will not go into the depth of it because this is not a, so, I mean, if in case you want to reach out to me, I'll share my email address. You need that if in case. So it is very easy. Here is one more example. How you can visualize the raster as well, right? if in case you ever asked one. And it also has something called as mosaic, virtual mosaic. Virtual mosaic basically for the benefit for the students are virtual. What is virtual mosaic? Let's suppose you have, as you can see, there are multiple tiles, right? When we are talking about in terms of GIS, you cannot, I mean, there's no specific information that is stored in only single tile because the data has been captured for a huge area, right? You need to stitch them and you need to combine and you can consume at just one single image. But with this, what virtual mosaic will do at the back end, at the database level, it will be multiple images, but at front end, it will become only one. So you don't lose the data quality, or you do not compromise on the data quality. You do not create another image, but you can actually virtually create a virtual mosaic wherein you can do a lot of analysis onto a single image as a viewability, but at the back end, there will be multiple images and you can extract the useful information out of it and it will be stored inside the database itself. Right. So this is a small walkthrough. You can explore Oracle Spatial Studio. These are a couple of links. If in case you need them, I can also share them in chat. If there is anything, any questions or anything, you can reach out to me. So that's
thank you.
Yeah,
Shahrukh.
thank you. I
So
can't hear
we have,
you. I'm losing your voice.
hello, can you hear?
Yeah. No, I'm losing your voice.
So thank you so much, Shahrukh ji, for your PPT. So before starting our open discussion session, I request you all to switch on your videos. I want to take the photograph of the screen. So please switch on your videos. Hello. So thank you.
Satish, can
Yes.
you stop sharing
Yes.
the screen?
Yes. Just a second. Just a second. Yeah, I have stopped sharing my screen. So
We
let's.
open the floor for question answers.
Yeah. Please.
Okay, so I would request our audience to please raise their hands and ask questions. We have our experts today with us who would be happy to answer your questions. Any questions?
Please feel free to ask. If you have any question, please ask.
I think there aren't any questions. If your microphone is not working, please type the question and we'll take it up with our experts.
Yeah, you can also type.
The presentations were completely, interesting and definitely gave us a very good insight of how geospatial technology is being used by the industry to provide solutions. So I would really like to thank all the speakers for bringing in this insights. Shivani Singh wants to ask the question. Yes, Shivani, please go ahead. You can unmute. Yeah. Go
Yeah.
ahead.
So actually, I wanted to ask to all the experts that we have seen today. We have seen several examples. So most of them belonging to either North American states or from the Middle East countries. So when we talk about India, so with this technology where we are lying at the present, and because I am from a conservation background, I'm a conservation architect. So if I want to use such data for my stimulation of like where I could study it, so how I can use it in Indian context, how I can get access to such data, so where we are standing. So that's my question.
Okay, let me answer to that. Shivani, as I have told you that, as I have shown in my presentation also, there are Indian users in a big way. So I have given you the examples of Airtel, as well as given you the examples of Jio. So they are using it for countrywide. And similarly, all the smart city projects which are happening in the country are geotagged currently. All the projects, all 7,000, more than 7,000 projects are geotagged, and that is regularly getting monitored about their physical progress as well as their financial progress. Okay. All the SBM projects in the country. So SBM is Swachh Bharat Mission projects. So how we are processing the waste, that is getting monitored continuously in the country using geospatial technology. Along with that, project at certain, there is a project named as NICDC, National Infrastructural Development Corporation projects, whereby BIM models are getting used, and as we are mapping out 5D project management, so which are happening over the BIM tools. So that is also there in place. And flood monitoring and all, this was specifically for urban cases, but otherwise flood monitoring has happened everywhere. Ganga Mission is monitoring the projects. They are directly integrating it with the sensors to see what is the quality of river, how the floods are happening. So it is not that they are not Indian cases. A lot means Geospatial technology has now become a forefront for taking any decision support system. In our country, you might have heard about the PMAY project, Prime Minister's Awas Yojana. So each and every house is geotagged in it, along with the beneficiaries detail. Now, when you bring that type of information on the GIS platform, you can do different levels of analysis. Like who are the beneficiaries, that we can divide into different segments in the basis of how many Divyang persons are getting it, how many old people are getting it. Right. Then you can do it with comparing it with the location, like where this housing has been constructed, whether they are inside the city or in the periphery of the city. Like if the houses are constructed for in situ slum redevelopment, and you are marking those houses outside the city, then people will be in trouble. They won't shift into that houses because it is not near to their residences. It is, and they have to spend on the commutation. Right. So that type of things are look at. Then you can also look into wherever the housing construction has happened, whether that is related to the water supply system and sewerage system, or they have been provided the houses without this connectivities. So that type of analysis are being undertaken by the ministries for looking into the projects. I hope that answers my question. For conservation, what type of conservation you are working into?
So ma'am, actually, I'm a conservation architect, as in I work for the heritage structures in general. So basically, I look into, so my question was in terms of like, for example, if I want to use GIS data in terms of to understand how the Plumbic system have been, as we were talking about different
Right,
kind
right.
of, right. So how can I get access to those data and use it for the stimulation
So
at the
that
present
you
point?
have to see. I believe that you might be using the this Revit products for that. Then you can put that over the, so Revit can be now integrated with GIS, which we call as GeoBIM. So when you put it on GeoBIM, you can understand each of the requirements. Okay, so where in what part, what type of conservation activities need to be carried out in the complete building can be overviewed. Again, it will be putting the continuous complete thing. If we bring it on GIS, it helps you in understanding the vicinity also. So a building is not an independent structure. So when this is attached with the GIS, then you can know how the accessibility can be planned, or how you can plan the green areas before the structures, and how the entire aspect of tourism can be developed around it. Right, so that is the benefit of bringing it on GeoBIM. But so it can be attached. This entire BIM model can be brought into GIS.
Thank you, ma'am.
Any other question from the audience? Hello. Please ask your questions if there are any. Okay. I request Shaily Gandhi to give her final remarks on the today's webinar. Shaily?
Yeah, thank you, Satish. Am I audible now?
Yeah.
Yes, ma'am.
Yes, yes.
Great. So, first of all, on behalf of CEPT University and Faculty of Technology, I would like to thank all the speakers from the industry and AGI to uh, take in, put in efforts and bring the industry partners on board to talk to our students. So, thank you so much for putting in these efforts and giving your invaluable contribution towards making this workshop a success. The presentations were very fantastic, and the work what each and every companies are doing is also very fascinating. This just does not let us know what's happening in the industry, but it also gives us a very good overview, especially for the students to understand where the future lies, how geospatial technology is advancing, and it's not just limited to as you know, some of the presentations very rightly mentioned that it's no more just remote sensing data sets. It's way beyond. It needs integration. It needs a lot of inputs from the ground sensors. Drones have evolved, uh, dramatically, and the applications of drones have been very effective. We at our research center also use drone acquired data for a lot of research projects, and by doing this true demonstration of the case studies or real life examples, I would say, rather than case studies, would give a lot of enthusiasm to the young um, professionals who would be in the industry in the coming years to understand and also bring out a lot of innovations in the sector. So once again, we extend our deepest gratitude to AGI and all the esteemed speakers for the day. Thank you, everyone. And we would also like to invite you all for the upcoming conference, what CEPT is going to host in October. So I'll just share the details in the chat box. Thank you. Satish, over to you.
So I also would like to thank all the speakers, and as Shaily has pointed out, the presentations were very good, and on behalf of AGI, I want to thank all the speakers and audiences for attending this webinar. and we look forward to have you in the next webinars. We will keep announcing it through the social media channels. Thank you all. Thank you for attending this webinar. Thank you.
Thank you.
Thank you.
Thank you.
Thank you, everyone. Thank you. Thank you.